Hello. So I am here. I got some questions on the homework, and I thought instead of just explaining one on one, I'd make a quick video showing how to do one of these problems because there's a number of people who are confused. So if you go in your book to page 2 here, well, first of all, page 1, this information is really good, but it's pretty tough to understand. So I thought to accompany this information, I'd make a quick video. If you look at problem number 7 here, I'm going to show how you can solve that. And something I wanted to stress, some students have been looking at these and saying, oh, you know what, number 5, this is a quadratic. P.S. The problems I'm doing right now, they're not the homework problems, they're the exercises. The homework problems are these ones here on page 3. I just don't want to ruin a homework problem for you by doing it and then you don't get the benefit of using it to study. So I'm going to do number 7. It's also a perfect problem to do. But number 5 is a quadratic, and it looks like, oh, I could solve it with a quadratic formula or completing the square or factoring or all these techniques. Excellent, but you don't need to know any of that stuff yet. Quadratics is coming up. It's like, what is it? Unit 3, you could see here if you go back to the table of contents, Unit 3 is where we start quadratics, and Unit 4. So we're way away from that. So we're just treating these as we've got one thing with a bunch of x's on one side of the equation and a thing with a bunch of x's on the other side of the equation. How can we solve that? And the strategy is that we're going to make a graph where y1 is equal to the left-hand side and y2 is equal to the right-hand side, or y3, y4, it doesn't matter the numbers. So first step for doing number 7 is that we're going to make a graph, and I'll paste it in here in just a minute. We'll use the graphing calculator to do it, and I wanted to show you how to make that graph. So here we go. So I'm going to enter in, I think on my calculator it's actually y3 I'm going to use for the x squared plus root x, and whoops, plus root x, and y2 for the 2x minus 6. It doesn't actually matter what the number is here. It can be anything. You're just going to use that to put it in. Okay, and here we go. Turn my graphing calculator on and go into y equals, and I chose to note, I'm looking over to the side because the thing I'm recording is over on the side and the camera I know is here, but just because I'm not looking at you doesn't mean I'm not paying attention. So y1 right here, this is turned off because the equal sign here is black on the green, as opposed to down here y2 is green on black. So to enter this in, I put y2 and then I use the 2 button here. Let me clear it out and do it again. 2 button, and then to put the x in, I use this button right here next to the alpha. That's for any variable. In this class you're only going to use x, but there's all those other kinds of variables that you can use. 2x minus 6, and it was 6, right? Yeah, I think 6. And then down below, to get the squared in there, I'm going to clear that out, and you do x, and then the squared is this button right here. If you wanted to do cubed, you would do oh, actually that's not right. Let me remember what's the equation. 2x minus 6, and then x squared plus root x. So x squared, I use this button right here next to the comma to do the squared, and then the plus button, and then the square root is actually, if you see this little notation right here, the square root is hidden above the x squared. So I hit second, and then it switches to the blue mode, and I get the square root in there, and then I can hit the x, and now I've got y3 equals x squared plus root x. And I hit graph, and I've got my graph. This graph has on it no apparent intersection points. So I think I did something wrong. Let's look at it. 2x minus 6, 2x minus 6, x squared plus root x. Maybe that's intentional. Let's see what the question says. Find their points of intersection. Maybe there's no point of intersection for this one. I would make this a bad example. Oh yes, that's not going to have an intersection. Let's zoom out just to be sure. Zoom out 3. Yeah, they're never going to intersect. What do I do at this point? You know what I'm going to do? I mean, the answer to the problem right now, you could see these never intersect. So the answer is just no solution. There's no, I'll use this. I think this is good. I'm going to stick with it. Stick with this problem in this video. So I get this here. Let's see this. Save image as there, and then paste that thing in here. Edit, add image. Desktop, where did I save it? I thought it was downloads. Oh. There it is. So you can see now that every point on this thing right here, every point, like that point right there, that point corresponds to 2 as an x value. And what would the y value be? Well, to find that out, I'd put 2 where the x is here. So 2 squared plus the square root of 2. That is 4 plus root 2. It's some number 4, a little more than 4. 4 plus the square root of 2. And I can see what the point is over here. This point here, for instance, is the point, let's say 1, 2, 3, 4, 5, 5, comma, and to figure that out, I'd take this 5 and I'd plug it in here for this x. So I'd get 2 times 5 is 10, minus 6, I'd get 4. So that point is 5 comma 4, right? So every point on this line is a solution to this equation. Every point on this curve right here is a solution to this equation. So if there was one point that was on both this curve here and this line here, well, then it would be a point where the x value would make the y value equal the same thing for both y2 and y3. In other words, it would solve this equation. So what I'm trying to do to solve this problem is just find a point that's on this curve and on this curve at the same time. And there's none. So the answer to this is no solution. Alternatively, let's imagine the alternate universe where we had, instead of this, we had the square root of x, we had a negative sign in front of this. So I'm going to do the problem over now, slide over to some space over here, and imagine that we're doing this problem over where, oh, come on, how do I slide? There, now I can slide. Doing this problem over where that x squared plus root x is root x minus x squared. So let's hit that. So we're going to do this. X squared minus root x equals 2x minus 6. So how do I solve that? Well, it's really the same thing. I'm going to plug in for y, negative x squared plus root x. I'm going to plug in for y3, negative x squared plus root x, and I'm going to plug in for y2, 2x minus 6. And then I'm going to graph those two and see if I can find a point that matches up for those two. So back to the graphing calculator, and this is a handy little trick that you can do here. Instead of having to rewrite this whole expression here where it says x squared plus root x, if I want to stick in front of that x squared a negative sign, all I need to do is I hit second and I choose the insert option. So second right here, this blue button, and then on top of the delete key is insert. So I hit second and then delete, and now it's inserting. And when I hit the minus sign, the negative sign, it doesn't write it over on top of the x squared, it puts it in front. So I saved myself the time of having to write that line over, so that's a handy trick. Then I hit graph, and I see that there is actually an intersection point now, and I want to find that intersection point. So we're going to try to find that intersection point. And the same technique, the same reasoning that we used before, the x coordinate of this point is going to give the same y value for the left side of the equation as for the right side of the equation. In other words, that x value will solve the equation. So I got to find the coordinates of that intersection point, and all I care about is the x coordinate, because the y value is just the value that you get when you plug it into both sides, and you don't care about that. You just want to know what number you plug into the equation to make it true. So here we go. We hit the second key and then the calculate key, and then we go down to option 5, and you can scroll down with the arrow key like this, or you can hit the 5 button to get to option 5. And it says intersect. And now on intersect, it gives you the question right here where it says first curve right here. And what that means is, out of all the curves, right now we're only graphing 2, so it's kind of confusing, but it's just saying out of all the curves that you've got, which 2 do you want to find the intersection of? And we're going to find the intersection of y2, and y3. So right now the cursor is on y2. I could switch to y3, switch back to y2, but I'm just going to pick one of those 2. It doesn't matter which one I pick first. I'm going to pick one of those 2, either y2 or y3. Hit enter, and then it switches automatically to the other one. And I don't want to pick y2 for the first one and then pick y2 again for the second one. I want to go with it switched to y3 already. I'm going to stick with that, hit enter, and now I'm finding the intersection of y2 down here and y3 up here. And now it says guess. What this guess means, the calculator does a lot of work to try and find the intersection point, and sometimes it takes a long time. So if I can get that blinking cursor as close as I can to the intersection point, it'll do the calculation faster. So I hit like that. Now I'm just about there. It's going to be close to 1.91, but not exactly. And I hit enter a third time, and it tells me, oh, the intersection point has an x coordinate of 1.8941826. Okay, so I'm going to save that image. It's down 1, 3, and then I'm going to switch back over here, and I'm going to show what we just did. Oops. So what we just did here is we managed to find the point that is on both of the 2 curves. It's on this y2. So if I take this number right here and I plug that in for that x, if I multiplied that number by 2, it's about 1.9 times 1.9 is about 3.8. And then I subtracted 6. 1.8 minus 6 is about, negative 4.2. What's 1.9 times 1.9 is 3.8, sorry. 3.8 minus 6 is about negative 2.2. That number right there. That's what I get out. If I take this right here and I plug it in for that x, I'm going to get out this number right here. What would happen if I took this x value and plugged it in for this x and for this x? Well, I'd have to use the calculator because I can't do that in my head. But I'd get out a y value that's that's exactly this right here. In other words, this x value makes the 2x minus 6 equal this, and it makes the negative x squared plus root x equal this. So what should happen if I plug it in to this equation here? Well, it's going to make the left-hand side and the right-hand side equal the same value. It's going to solve it. So I'm done. All I have to do is graph the left-hand side. y2 equals the left-hand side. y1 equals the right-hand side. Find the intersection and write that x value down. So 1.8941826 is the answer to this made-up equation right here. It's not actually even a problem. It's certainly not a problem on the homework. It's not even a problem in the workbook, but there's the answer. I wouldn't get full credit though because I'm supposed to round to the nearest third decimal place. So I look there and I say the right of the third decimal place is a 1. That is not 5 or larger, so I write down 1.894 as my solution to the equation. Thanks, everyone, and I'll see you in class on Thursday, tomorrow.